Okay, hi everyone. Thanks for coming. My name is John Blischak, and today I'll be talking to you about contributing to open source. So quick about me if you don't know me. So I work remotely as a postdoctoral scholar in the Department of Human Genetics at the University of Chicago. A lot of what my job entails is helping biologists and statisticians do their computational research. So to that end, I developed an open source R package called Workflow R, and it combines R Markdown, which you probably know, with Git for version control to help anybody be able to create reproducible analyses. Especially more for scientists, but anybody doing data science can also use it. And for more details of what I've been up to, you can go to my personal website. Okay, so what is open source software? So presumably you're either curious about it or want to learn more since you're here. So from an analogy of the sort of open source framework, imagine the Encyclopedia Britannica. So their business model is they pay experts to provide content, and then the users or readers pay money to get those books. And if you don't pay for the books, you don't get to read it. And if you're not one of those experts, you don't get to contribute to it. So in contrast, you have something like Wikipedia. This is a free encyclopedia. So anyone can contribute content. You don't have to be one of these experts that they identify, and then it doesn't cost anything. Anyone with an internet connection can read Wikipedia. So in the software world, a good example is Microsoft Office versus LibreOffice. So Microsoft Office, new features are implemented only by Microsoft software developers, whereas LibreOffice, bugs can be fixed by anyone who's interested in participating. And similarly for an end user, if you don't have a license, if you haven't paid for a license, you're not running Microsoft Office. But anyone who can download and run LibreOffice. So this is sort of the open source framework as opposed to the proprietary closed one. So the basics of what I was just talking about. So anyone can inspect, modify, or even redistribute the source code of an open source software project. And anyone can run the software, so you don't need a license or anything like that, and for any purpose. You can't create open source software and say, oh, only biologists can use this for their research. No one else can. Once you, if it's open source, anybody can use it for whatever they want to. This is not like a required part of it, but a lot of the times it's the motivation. So we're talking about Wikipedia or LibreOffice. You can do this sort of open source collaborative development where you can get a group of people together. Anyone can hack on the software, try and fix bugs, and try to improve it. And the way you know it's an open source project is it will have an approved open source license. And that way we can get a little bit more complicated. I gave you the basics, but there are specific criteria to what is and is not an open source license. And so there's two main authorities, the Free Software Foundation and the Open Source Initiative. And from a pragmatic standpoint, they're very similar. So here's a quote from Richard Stallman of the Free Software Foundation. Nearly all free software is open source, and nearly all open source software is free. But philosophically, they have a lot of disagreements. So if you were to go online and wanted to go down sort of a rabbit hole, you could find lots of heated debates online as to which of them is philosophically correct. But we're not going to get into that today because this is a pragmatic talk. So for the purpose of this talk, they're the same. Like I said, if you want to hear about people who would very much disagree with that, just go online and you will find the disagreements. Okay, so pros and cons of the open source model. So a big pro is it's widely available. Anyone can access the internet, can access the software, and download it and run it. For successful open source projects that attract a lot of contributors, that's lots of eyeballs looking at the code, many more than, say, a private company has working on their software. So the idea is with enough eyeballs, all bugs are shallow. Someone will find the bugs. This is known as Linus's Law, named after Linus Torvalds of Linux. Another big thing is there's no vendor lock-in. So even if there's a primary company sort of backing the open source project, if that company was to go bankrupt and stop developing it completely, the source code is still there. If there's a community around there, they could keep it going. They can keep developing it and distributing it. So cons is because it's all volunteers, there's no instant customer support. If something breaks, there's no one to call. You have to go look at the documentation yourself. You have to go on the support forums and try and troubleshoot on your own. And because it's not back, there's often not a business model associated with it. It can be difficult to long-term maintain and the sustainability of the group. So as long as people are interested and are contributing, it's good. But if people start getting disinterested or get burnt out, then it can go into an unsustainable mode. Okay, and so an example of a very successful open source project is R, as you shall know. It's a free software environment. That's the first sentence on if you go to the R project's website. Furthermore, not only is R open source, but most of the CRAN packages are as well. So I did a quick looked at all 14,000. And so there's this field you can set, a package author can set called license restricts use. So this is probably a lower bound, because certainly some people probably don't know about it. But only 11 of the 14,000 specifically say you can't, it's not an open source license. So like I said, there are probably more out there, but it's not like a common practice. That's what I'm trying to say. Okay, so if it's already free, so why contribute, right? Okay, great. Why should you start contributing? So there's lots of reasons. So one is learning. So this is any open source software community is going to have a bunch of experienced software developers. So if you want to learn best practices, this is a great way. You'll see how they do things, and also when you submit a contribution, they'll give you feedback on how to improve it before it'll get merged into the code base. So it's a great way to get a lot of really direct feedback from experienced people. And also, when you contribute to an open source project, even though you might be contributing something small, you're contributing something that's actually going to be used by people. For example, in contrast to like an assignment in a course, you may create some toy software project, but neither you nor anyone else is ever going to use that. And hundreds or thousands, depending on what the kind of course it is, have created the same exact thing. So it can be motivating to contribute to something that's actually affecting people. It's also a great way to network. So for example, we're all here because we live in the greater Cleveland area and like R, but if there's a technology that doesn't have a local meetup or you want to expand beyond this area, finding an open source project that uses that technology or is that technology is a great way to join the community and meet others with those similar interests, even if you may be geographically very far away from them, or maybe you don't have the time to go to a meetup. And one of the reasons I contribute most to open source projects is to prioritize my own interests, and that's a lot of way people get roped in. So if you rely on open source software for a critical part of what you do at work or for your hobby, if there's a feature request you really want to get implemented or you need a bug fixed now, if you're a long-term contributor to the project, you can get that done. Whereas otherwise, you have to ask for people and wait. And if someone else isn't interested in that feature or if that bug is only affecting you, it can sit for a long time because, again, it's all volunteers. So again, if you're already experienced and already been contributing, you can get that fixed much faster than waiting. Okay, so what does contributing actually look like? So we'll go over contributing code, but I want to stress that you don't have to be committing code to be supporting an open source project. So there's lots of ways to do it. So for example, you could be supporting other users. So you can answer user questions for that technology, say answering R questions on Stack Overflow or RStudio Community. You could write a tutorial or blog post on how to use the software to solve one of the use cases you use often. And you can look at the bug reports that other people have submitted. If you tried to reproduce those, that's a big help for the core developers to know that it's not an isolated incident, that it is reproducible. It can be super helpful. Giving recognition, all software projects need to show if they're trying to apply for grants and that sort of thing that people are using it. So if you're an academic and you're writing a paper, citing that software is critical. If you do other official reports for your work or your institution, that can be really helpful. And again, if you needed to solve a problem and a specific open source project helped you do that, sharing on social media is a great way to let others know about the project. And financial support is critical. They may need infrastructure costs for hosting various parts of the project, like the website, sending people to conferences, mentoring new contributors through programs like Google Summer of Code. Money always helps. So you can support a project. So for example, if you wanted to help support R, you could donate to the R Foundation. And then there are also umbrella organizations like the Foundation for Open Access Statistics and NumFocus. So what they do is they handle the finances for a whole bunch of different open source project. So if you wanted to say support development of NIDR, you could submit to you could finance that through the Foundation for Open Access Statistics. You could also support a specific developer you like. If there's someone who you like who does lots of cool things, they may have an account on a thing like Patreon or Buy Me a Coffee, where you can throw them a few bucks to help support their work. And also, a good way to get money is if your company or institution relies on open source software, convincing them to help support that critical business need is crucial. So there are various companies like Tideflift and Quansight, and what they'll do is your institution pays them, and they work with open source developers to prioritize the sort of features and bug fixes that the company would need. They're sort of like a go-between. And also, always a good way is purchasing the enterprise versions of open source products helps keep the open source version available to everyone. And then building community, as we're all doing here. Organizing and attending community events is a great way to support an open source project. And of course, giving a talk. So Tim and Jim are always looking for speakers. So if there's an open source R package you like to use, volunteering to give a talk is a great way to support that, that package. Okay, so those are all non-code ways to contribute. But if you are committed to writing code or documentation, this is going to require some more technical skills than the previous ones. So you're going to have to learn how to use whatever development tools that project has decided to use. So this typically includes some sort of version control software, like Git, Mercurial, SVN. And this is how they keep track of all the changes they make as they update the software. And you have to learn the peculiarities of whatever hosting platform they use. So whether that be GitHub or RForge or Bitbucket or GitLab, these are common ones. They're all slightly different user interfaces and have slightly different terminology and documentation. So if you want to contribute to R packages that are on CRAN, I would suggest that you start with Git and GitHub, just because it's the most used. So this is a quick, just looking at the URLs that package authors provide in their packages when they submit them to CRAN. So if you look at, on the right are active projects, which I defined as an update to CRAN within the last year. Half of them are developed on GitHub. And then of older projects that haven't been updated in the last year, about a quarter are developed on GitHub. In contrast, RForge, Bitbucket, and GitLab, all of those combined only account for a couple % of both active and less active projects.
Can you talk really quick about the differences between them? Because you use the Git language for all.
No, I think RForge is SVN, which is a different one. Bitbucket used to support Mercurial, but they're phasing that out. So that's all Nelson to Git. And I don't know about GitLab, if you can use Mercurial with that or not. Anyone? No?
I'm not sure. I don't know. I think it's just Git, but I don't know for sure.
Okay. So yeah, Git has become the most popular, not because it's the most intuitive. It's just it's, people learn it and then they keep using it. But yeah, so RForge, which predates all of them, and is focused specifically on R packages, so it has a lot of nice things specific to R, but that's SVN based. Good question. And who knows, the big blue is the other. That's just if they don't, I couldn't tell from the URL really easily scraping it what it was. So these numbers would change if we actually knew the truth of where all these things were. Okay, so what is Git? So it's version control software. So if you've never used it, so it tracks the changes made by each contributor. So think like track changes in Word where it'll highlight what each person did. And it also logs each of these changes with a unique ID. So think about like the version history. If you've ever looked at that on Google Drive, you can go back and look back and see each version. If you click on it, it'll show you the changes made in that version. And you can even restore in Google Drive to go back to that version. Git allows you to do that for your code. Now, the nice thing is that it requires a message saying why you did what you did, and the more information, the better. So, for example, look at this. I don't know. I have no idea what any of these changes, like this change I made at 4:35 p.m. on July 30th, I have no idea why I did that, right? I would have to click on it, look at it, and try and guess what I was thinking why I made that change. Whereas I was using something like Git, it could say like, oh, I updated the methods paragraph. Right? Okay, and so something like Word track changes or Google Drive, that instantly, adds and updates the document based on what you're doing. So Git's a lot more cumbersome than that, but that allows for more fine-grained control of your edits, which is critical when something like in our code, one little misplaced bracket and the whole thing's broken, right? So you really want this fine-grained control. So we'll use an analogy of sending a letter. So when you're editing code files in an open source project that's using Git for version control, this is like writing letters. So you're writing multiple letters, you're editing multiple code files, right? So the first command you'll use is git add. And what that's doing is like when you're done with writing one letter, you put it in the envelope. But that might not be the only envelope you're sending. You might be changing multiple changes in various files. You might be sending multiple letters that are all need to be going together, right? It's like all your tax documents. They all need to be together. So as you edit files and you add them, once they're all complete and ready, then you commit them. And that's like sealing the envelope. So you've got all your changes. You're ready to send them off. You seal it. It's finished. It's final. No more changes can go in that envelope. If you want to make more changes, you have to start a new envelope. And then finally, you're going to do git push, and that's like putting your letter in the envelope. And so that's going to send it off to GitHub or RForge or wherever to the project, sending off your letter. Okay, so that's what you're going to be doing locally on your computer, but that's just what you're doing. So you're collaborating with lots of different people. So before we get into how GitHub works, let's think about a more traditional sort of editing a Word document via email, right? So you send it to a collaborator, they send it back. They use track changes. It's really easy for one person to just go through, okay, accept, reject, right? It merges it pretty nicely, right? But when it gets bigger, so let's say you send it to 3 different people by email. And as they each send it back, maybe the first person you can merge, but then the second person's merging changes, they don't have the other person's changes. So then you're sort of trying to get those together. And then if people edit the same things, it's just all disconnected, right? And so as an open source project scales, this sort of method would never work, right? You'd never be able to, all these different people working asynchronously and then someone trying to word track changes it all in at the end, because they've all edited different versions. So here's how it looks on GitHub. So there's the main project. So this is the main source code that everyone downloads and installs, so like LibreOffice. So anyone, they don't have to receive an email from them. Anyone who wants to contribute, they can fork it. That's the GitHub terminology. Make their own private copy. So they'll make their changes, do all the things that we were talking about, like sending letters. They send a pull request to the project. They'll review it. They'll either request more changes or merge it as it is. And then the code base will be updated. And the reason it scales a lot better is if 3 different people fork it at the same time, they'll start making changes. And then as they send in their pull requests, they can be merged, and Git's a lot better about this. So if they're all editing different files, as each person edits their change, they can just update that particular file, right? It doesn't need to worry about that at all. It'll be smart about it. And if there ever is a conflict, so let's say this person tries to edit something that the other 2 already had, well, they can easily just pull in the latest changes, update it themselves locally, and then send it. It's not on the maintainer. So think about it, a poor open source maintainer with getting a bunch of contributions. It's not on there to fix it. It's on the contributor to bring their stuff up to date and add their changes on the latest version. And this scales a lot better than email. Okay, so I talked about on your local computer doing the mail analogy. On GitHub, you're doing the large-scale collaboration. How do you connect the two? So again, you find a project you want to contribute to, you fork it. The command you'll use from Git and your terminal is git clone. And that'll bring the source code into your computer. Then you'll make your changes, you'll do your edits, git add and git commit them. You'll push them back to GitHub with git push, so send the letter, and then you'll open a pull request on GitHub to show your changes, to ask for your changes to be merged into the main project. So all the letter stuff happens on your computer, and then the forking and pull requesting, that's all GitHub specific stuff. If you were to go onto like GitLab, I think GitLab calls it a merge request, right? It's all be slightly different words depending on the user interface, whatever platform you use. All the Git stuff will be the same though. Any questions about this? Okay. So because that was fairly high level, I just wanted to show like a quick screencast, just showing sort of round trip what that looks like on GitHub. So on top of each one, there'll be a fork button. So if I clicked fork, And what that's going to do is take this spoon knife, which is an example one from GitHub, and put that into my account. And hit the clone button and get that special URL. Go into my terminal, run git clone, and paste that URL. What that's doing is that's pulling it down into my local computer. Then I'm going to go into that directory and I'm going to do all the mail stuff. I'm going to use the text editor Nano to edit the README. So I'm just going to add a quick little edit at the bottom of it. Save it. So now I do git add, so it's adding it to the envelope. Git commit, it needs a message. The more informative, the better. Here I'm just going to write a change. So that's sealing that envelope, and I'm going to push it back up to GitHub. So going back to GitHub, you can say new pull request. And so it automatically shows the change I made. So there's that commit I made, and it shows you all the edits that came along with that change. And so then there's a box there that'll say that's where you justify what you're doing. Like, oh, I found this bug, here's how you reproduce it, and here's the fix. Or you might say, I wanted to implement this new feature, this is why I need it, here's what I did. And then they can evaluate it. They'll either merge it as it is, or they may request changes, and you'll need to update as they request things. And so I've linked at the bottom. I'm going to put these share the slides on the Meetup site. The link to that repo I just forked and did a pull request, and then 2 different GitHub guides how to fork a project. They'll have nice step-by-step instructions to recreate what I just did. Okay, so if you don't have a specific project in mind, you just want to get started and gain experience and learn. So GitHub has search filters. So for example, you can search by language. So if you do language R, that'll show all the repositories on GitHub that are primarily R-based. And you can also, on GitHub, they're not called bugs, they're called issues. So you can look at their sort of a mix of bugs and feature requests. So they can have labels. So open source projects that are looking to get new contributors, try and label them to help you find them. So if you do label help wanted or label good first issue, these are ones where they're saying, we want to mentor new contributors to contribute to our project. So that's a good way. Searching for language R in one or two of either of these labels is a good way to get started and find a project that's mature enough and has mentors available that could walk you through this. And if you want to do a practice run where it's low pressure and you're not actually contributing really to an open source project, so I co-wrote a tutorial to use Git and GitHub, and the final sort of assignment is submitting a pull request to our repository on GitHub. So if you want to go through the whole process of actually pressing create pull request and having us merge it for you, so you can see the whole round trip, you can go to git-for-science, and you can find the paper and read through the instructions. And then when you actually find a real project you want to contribute to, it's not as intimidating. Okay, some more advanced topics that we can talk about at the end if people have questions, but this is more just if you ever come across these things, to know that these things exist. So if you start contributing a lot to an open source project and you're trying to do different changes, you might want to use Git branches to have different sort of develop them in parallel, right? So Git is super powerful, so you won't want to mess with this when you first start, but you can have multiple in parallel versions of your code in the same Git repository. So if you're working on a feature while also trying to fix a bug, you can do those at the same time. So this is not something we'd want to look at the beginning, but if you've been contributing to a project for a while and you realize you're trying to handle a lot of different things, looking up Git branching is what you need to solve that problem. One thing you might be asked, or you might notice that you're having trouble getting your contributions accepted, is that if you add tests, so if the software has a test suite, adding tests is a good way to get your code fast-tracked, right? So if a maintainer sees that you have tests in there and they pass, they're much more likely to just merge it, whereas if they have to add a test themselves, or if they have to coach you through doing that, it'll take a lot longer. So taking the time to learn the unit testing framework they're using is a good way to get your pull request accepted. And lastly, so we're talking about how some open source projects are backed by companies, so they might want you to sign a contributor license agreement. And this is just saying that your you accept the open source license, right? That you're not going to try and claim any rights to your contributions. Okay, so that's the overview of how to do it. So now I'm going to give you some advice on getting started in open source. So my first piece of advice, like I've said, is to start small. Don't try and tackle some big problem because there's lots of just technical issues of learning how to use Git, getting comfortable with GitHub, learning the social interactions and dynamics of the project. So try and find something small you can do to contribute to the project, like improving the documentation. Most open source projects struggle to find the time to work on the documentation, so if you improve that, that's an easy way to get a first contribution merged. And so, for example, from my journey into open source, one of the first things I did all the way back in 2014, I was reading something and the documentation was wrong. So I submitted a pull request and they merged it, and I felt good about myself, and I was motivated for the rest of the day. Right? It's literally I changed one line. Right? It's not actually that much work, but it feels like official, right? Because that was now on the web, right? And so, continuing on this sort of thing, there's a site called firstpr.me, which can be very motivating. So what you can do is you put in a GitHub username, and it'll show the first ever pull request they made on GitHub, right? So you can see sort of how far they've come in their journey, and realize that you can start small as well. It's not going to limit you. So for example, if you do it for me, it's nothing code related. I was helping teach a workshop, so this is all lesson material. It's not a code contribution. And so if you've heard of Hadley Wickham, so of RStudio and Tidyverse fame, his first was editing a README. So even Hadley starts small. He didn't invent a whole new package or redo statistics on his first pull request. Just to edit to a README. Hillary Parker, she's a data scientist at Stitch Fix, and she's the co-host of the Not So Standard Deviations podcast. So her first one was she was editing a README, right, making it easier for people to read. Julia Silge, she's a data scientist at Stack Overflow, and she's also the co-author of the TidyText book. Her first one, she was attending an ROpenSci conference, and she was adding her affiliation. And then Emily Robinson, she's a data scientist at DataCamp and is now writing a book for Manning on how to start a career in data science. And her first pull request was fixing some typos in the R for Data Science book. So you can start small and go to very big things, but you got to start somewhere. Okay, so most of your sources, because it's so distributed, it's all going to be via text. So you want to assume the best for online interactions. So when you're really just reading text, tone of voice can be really hard to decipher. If you're into that, the new book, Because of the Internet by Gretchen McCulloch, I highly recommend. It was a fun read. But there's all these different conventions for text, and they're always changing, and it's generational based on when people started on the internet. So when in doubt, just assume good intent. And if you've had bad experiences like on forums or something in the past and you want to make sure the project's going to be safe, a good way to check is if the project has a code of conduct. So projects that try and be very welcoming to newcomers and very friendly often have a code of conduct. So you can look at that first before you invest the time and contribute to the project if you're worried about that. Okay, this is generic advice, but applying it to open source is very important. So compare yourself to past you. So when you first start a project, you know nothing about it, right? Where all these long-term contributors, everything you ask, they'll know the exact reason for every quirk and every reasoning for why everything was done. They'll know all the different personalities involved, and you'll know none of that. And so it's really easy to feel imposter syndrome when you first start on a project. So what you want to remember is always compare yourself to yourself over time. Look back 6 months ago, a year ago. Think about how much you've learned about this project. Don't compare the people who've been working on it for a decade, because you're not going to reach that, and that's not the point, right? But to make it go smoother, you do want to do some due diligence. Most projects have a README and maybe some frequently asked questions. This is a good way to not get curt responses on the mailing list or forums. A lot of times there'll be contributing instructions, and in the convention in GitHub is to have a contributing.md file where those are. So if they want you to follow a certain style for the code or sign like a contributor license agreement, those sorts of things, you'll see that there in the instructions. And a lot of times you can search, so if they're primarily on GitHub, you can just search the GitHub repository, but they might have a forum or a mailing list or a discourse site or something like that. Searching real quick for your issue, especially if you're new to a project, is a really good way, because they might have an alternative way they want you to solve your problem, or they may have discussed it at length in the past and decide not to solve the problem the way you want. And so you don't want to ask the problem yet again if they've already discussed it. Okay, so here's a bunch of additional resources for getting started in open source. Like I said, I'll share the slides. You could click around and look at these once I share them. And with that, I'll take any questions. Yeah, Andrew.
The main difference between GitHub and Git, it's the coding language, and then GitHub is the repository. Can you expand on that a little bit?
Okay, so the question, yeah, what is the difference between Git and GitHub? And yes, it is confusing. So Git is software for doing the version controlling. So it is doing the thing where you're adding, you're committing, and it's keeping those unique identifications of each version. And then what GitHub is it's an online web service, a web app, that understands that you have a Git repository and use that information in the Git repository to build a whole bunch of nice user interfaces that you can point and click, right? So, so basically, GitHub could not exist without Git, but anyone could build a new, that's why there's all these competitors, GitLab, Bitbucket. You could build one yourself, a basic one. You're just building user interface on top of it. Is the idea. So it's like a Git, what I call is a Git hosting platform. It's a place for adding a lot of social aspects, like the reviewing pull requests and messaging and that sort of thing around it. But at the end of the day, it's Git operations under the hood that are affecting the Git repository.
Okay.
A GitHub might call it, like when you do a pull request and the person says accept, right, clicks that button, it's doing a Git merge underneath the hood. So it's running a Git command. So good question.
It varies based on the project, but is there a, when you just open source in general, the community in general, is there a revised way of trying to synchronize with the master branch? Is basing, merging, is there certain best practice overall?
Okay, so the question is about rebasing versus merging. So that's an advanced Git question. So, and what's the best practice on a project? For a pull request, I mean, as an open source, both contributor and maintainer, I like when it's rebased. I like a nice clean pull request, but especially when it's a new contributor, I want them to just merge and, like, I don't mind the bubble commit from the merge because I'd rather get their change in and updated than worry about a clean commit history. So yes, if you know how to rebase, rebasing it makes it a lot easier to read and follow for the maintainers reviewing it.
For pull requests, with rebasing generally have to be forced.
What was that?
So git rebase -f or whatever to force the rebase. Is that necessary usually for a pull request, or is it sometimes possible to do that without?
Are you asking as the contributor or the maintainer?
As the contributor.
I mean, as the contributor, I usually rebase my changes locally, right? So if they ask for a change or I need to pull from, they've made changes upstream that I need to pull in, usually I'll pull those in and I'll rebase my feature branch onto the master branch, right? And then I push it, force push it back. Yeah, you push back, force it, yeah. Because it's just your feature branch on your fork, so it doesn't matter if you overwrite that a bunch of times. So yeah, my advice, just like writing unit tests, if you rebase it and keep it nice and clean so that they can see exactly what you've done and not try and guess what's going to happen or have a bunch of merge commits in there.
To be clear, rebase means to incorporate the changes that may have occurred on the master branch back into your fork, right? That's what you mean when you say the word rebase?
Yeah, so this is getting into it, so that's why I was just using the Git command, because if either you know what they're talking about or not, but the idea is that, remember how I was talking about how, here, I'll go back to this slide. On this slide where I was saying it doesn't matter, it's like if they're editing different files, it doesn't matter as much. Git can figure out how to merge it all together. So when Git, so if these two repositories had added a commit at different places, Git will resolve that and make what's called a merge commit. It'll sort of say, okay, well, there's all these different trajectories, but they're editing different things, so I can figure out how to combine them and then make this merge commit. And that makes it a little harder to follow the development of the project. So what he was asking is best practices if I'm submitting to a project and I need to pull in the the changes that have been made since I originally, let's say you make a change, it's been a month, a lot of changes have gotten merged in. If they're different to different files, you could just merge that into your pull request, but then you're going to have a merge commit there, and that can make it harder for the maintainers to review. So rebasing it, what you do is you merge the changes, and then you replay yours on top. So it's as you're like sort of changing what really happened and saying, I didn't make a change in here. What I did is I really made a change when the code looked like this. And as long as the unit tests pass, it doesn't matter. So it's all about keeping your history clean of when it was merged into the main project. Like I said, that's not something you should worry about at all if you're making your first contribution. This is more long-term if you start making bigger changes or want to do it the best way. Good question. Yeah.
Can you talk a little bit about how this relates to like the actual packages that you access in R? Like, is this before it's available to install from CRAN, or after, or both? Or?
Before. So this is where the developers choose to develop it, right? So they could choose wherever they could. That's why that plot with the different platforms. An R package author could do it wherever they want. They could be only on their local computer, but then they can let's see where it is. I don't know where it is. Anyways, so they can choose wherever. So GitHub just happens to be popular now in 2019. So if you're watching this on YouTube, it's 2019. We were all using GitHub. That's so lame. I'm sure you're using something else now. So yeah, tides change, right? So, but this is all where it's happening. And so once the author decides that enough changes have been made to justify a new release to CRAN, then they bundle up the package and send it off to CRAN. And that's when you'll be able to do install.packages. So if have you ever used install GitHub, the function? So if you use it in DevTools or the remotes package, so let's say you install the version from CRAN with install.packages, and something's wrong. So then you go to GitHub and you see on there's it was already been fixed on the GitHub development version, right? On GitHub it's fixed, on CRAN it's still broken. You can use DevTools, install GitHub, get the development version, keep on coding, instead of having to wait a month until the maintainer updates it on CRAN. So this is definitely beforehand.
So what's the process for updating CRAN? Can you just make anything and put it on there, or?
No, there's lots of checks. So what you do, so as a package, so for my package, so I develop it on GitHub. I have a whole bunch of tests that I run, and there's various. So there's a command. So R has ways to check its own packages, right? So there's a command called R command check. And what that's going to do is run its test and run a whole bunch of other checks to make sure it looks okay. And so when you upload your source tarball to CRAN, it runs R command check on a whole bunch of different platforms. It's going to run it on Windows. It's going to run it on Mac. It's going to run it on Linux. It's going to make sure it passes. And if it passes, then it will make it generally available to the end user. So that's sort of the process. You develop it, and when the maintainer uploads it to CRAN, then it goes to the checks. And if they fail the checks, then they tell you to fix them first. Good question.
So this is not really specific to R, but open source in general. So in academic publishing, how do you negotiate when you release something on GitHub during the publishing process? Would it be after or before publication?
Okay, so the question is if you're an academic and your software is associated with an academic manuscript,
Yes,
right?
correct. If there's code specific to it that you want to release.
That you want to release. Well, I would encourage you to just have it on GitHub all the time. But if you were not comfortable with that, GitHub has the option for academics to have private repositories. So if you weren't comfortable and you wanted to wait till you released the paper, you could wait until you submitted the paper or it was published to do it. Well, you'd probably want to do it when you submit it so the reviewers could look at it. Is that getting at what you were asking?
Yeah.
Because journals aren't going to care. Journals only care about the paper, right? They're not going to care about when you release the code. So as far as a technical journal issue, there is no issue. It's when you feel comfortable releasing it. That being said, I would suggest you release it whenever it's ready and not wait for the publishing process. A personal anecdote is I used, for one of my research papers during my PhD, I used a software, an R package on Bioconductor that they released, and they released a preprint describing it, and it didn't get published until a month before I submitted my paper. But that whole time I was able to use it and do it for my research, and they got a citation the second they got their paper out. Whereas if they would have waited and sat on it for like almost a year, I would never have discovered it, and they would have, I wouldn't have been able to use it. So personally, I prefer open science, and if you can, and your advisor's okay with it, I would get it out there whenever it's ready.
It's corporate. I guess how since the contributions would be voluntary, most of it. What's an appropriate length of time between actions and responses? So if someone asks for something, somehow should fix, should you do that exact same night? Should you wait a month? What's the appropriate amount of time?
Okay, so the question is like how, as like a maintainer or contributor, how long should there be between interactions, right, in an open source project? If you ask, you mean like submitting a bug report or something like that?
There is, yeah.
Yeah. I mean, there's no hard and fast answer. It's going to depend on how big the project is, how many users. The problem is usually as you get more contributors, then there's also more users, so it can be a tough problem. But I try at least have it on for my package. I don't get that many issues, so I usually try and have an initial response like within 24 hours. That's just my personal way to at least say I recognize and maybe ask a couple extra questions. To actually be able to solve it, it depends on what they're asking, how quickly I can solve it. But that part is you'll see that from the open source project. You'll have to look at other, like if you're worried about yours not being answered, you can look at how fast other passed. And that's a good way to see, like, is mine taking longer than usual? And that's usually one thing you can do is, if you like submit a bug report, having a reproducible example, like something that they can run easily and reproduce that's small, you're much likely to get a quick response, because if they're tired, they might still do it. Whereas if it's just a copy-paste jumbled mess that's not formatted and they have a headache, then it's not going to get answered that day, right? So the easier you can make it for the maintainer, the more likely you're going to get a response, no matter what the project or how many contributors there are, or maintainers. Yep. Okay, all right. Thanks for all the questions, and I'll be happy to follow up with anyone who's particularly interested afterwards. Thanks.